Jai Shri Gurudev. Our next problem is problem number 43. A cube of 40 sides rests on HP on an edge which is inclined to VP at 30 degree. Draw the projections when the lateral square face containing the edge on which it rests makes an angle of 50 degree to HP. Now here identify the type of solid. What is the type of solid here? The type of solid is cube. See the cube here. What do you mean by cube? Cube having a square base, square top face and square the lateral surface. Means all dimensions, all edges. It may be a base edge, top face edge or lateral surface edges. All edges are equal in dimension. This cube is also called as hexahedron. Hexa means six faces. all sides are equal, right? What is the size is given? 40 right? Okay. The cube, the type of solid is given cube, or is called as hexahedron. 40 sides. Sides is how much? 40 Rest on HP on an edge which is inclined to VP at 30 degree. Resting on what? Rest on HP on an edge is a edge condition. Where it is rest? Is rest on HP. Then what is condition? Second condition given? Resting edge is inclined to VP at 30 degree. That you show in HP, right? What are dimension given in VP? That you have to show in HP, right? Then the lateral surface. Draw the projection with the lateral square faces containing the edge on which it rests makes an angle of 50 degree to HP. The lateral square surface containing the resting edge is at an angle of 50 degree to VP. That dimension you show in, the 50 degree to HP, that you have to show in VP, right? Now the first position is rest on HP on which condition? Edge condition. What is second condition? Second condition is this one. The lateral square surface containing the resting edge, an angle of 50 degree to HP. Third condition, resting edge is inclined to VP at 30 degree. Now draw a horizontal line, name it as XY line. Above X1 is VP, below X1 is HP. Now is given the condition. What is that? Is a cube of side 40 rest on HP on an edge. Always take the edge, resting edge on right side, right? Now draw here is a square. So surfaces, bottom and also top of the square, right? This is similar to our square prism. But square prism, what is the rectangular faces are there? The height, the axis is higher than the base side, but here the axis is also equal to the base side. That is a hexahedron or cube. This is similar to a square prism only, but length is equal to axis length is equal to edge length, right? Similarly, what we follow the square prism, same method you follow here. Take the resting condition on the right side. Now draw the square surfaces on top and bottom. Name it as A, B, C, D. Top surfaces, bottom surfaces are invisible, bottom corners are invisible corners, that is A1, B1, C1, D1, that you kept in bracket. The center, top sub center is O, bottom center is O1. And show the dimension. That's complete the first position. Top view. Now the resting on where? Rest on edge, that is C1, D1. C1, D1 is the edge, resting edge. Now project all the corners vertically upward. 1 minute. Project all the corners vertically upward. The base corners you can see here, that is corner B1 dash visible, A1 dash invisible, C1 dash visible, D1 dash invisible, O1 dash. Now from the O1 dash, what is the height here? Is a cube, right? Height also, the slant edge also, it's a 40 only. Take 40 from the all the corners vertically upward, then make it is also a square, right? That completes first position, top view and front view. What is second condition is given? The lateral square surfaces containing the resting edge at an angle of 50 degree to HP. That you have to, whatever the dimension given HP, that I want to show in VP, right? Which is the lateral surfaces? Lateral surfaces C1 dash, D1 dash, C dash and D dash. This is the lateral surface. That also is square. That has to tilt. How much angle with respect to XY line it is? Draw a 50 degree line. Just transfer this square, cube on the 50 degree line. 50 degree line, right? Now you know how to, with the help of compass. First you draw to the projector, draw a 50 degree line. Along the 50 degree line measure C1 dash, C dash, that is a 40 mm. Once you get the C1 dash and C dash, draw a 90 degree line. Along the 90 degree line also measure 40 mm. Then you will get B1 dash, B dash, then join it. Then you get the center. If total is length is 40, center is 20 mm, 20 mm. Then join this, you get axis. That completes second position. Front view. Then draw vertical projector from the base corners and top face corners vertically downward, and horizontal projector from first position, top view horizontal projector. So don't make confuse here. First, better you go for a bottom face corners vertically project it, means the base corners first vertically project it. Here A1 dash, B1 dash vertically project it. Now here A1 horizontal projector, B1 horizontal projector. Then immediately name it that corner A1, B1. Similarly C1 dash, D1 dash vertical projector. Then C1, C1 and D1 horizontal projector. The intersection point will get C1 and D1 and name it as. Then how do you get O1? O1 dash, draw a vertical projector. O1 horizontal projector, the intersection point is home. Similarly go for next, we'll go for top face corners vertical projector and top face corners from horizontal projector first position top view. Similarly you do that, will not make confusion about the corners, right? Then apply the visible and invisible lines or edges rules. What is invisible, invisible? First rule is all outlines of the solid is visible. That is A1 dash, A1, B1, B1, C1, C1 to C, C to D, D to D1 and D1 to A1, right? Now after this, now see here, observer here, the corner A dash, B dash, those are nearer to the observer, means corner A and B is near to the observer. The edge which is passing from the corner is also visible edge, that's why it's a continuous thick line. AB is continuous thick line. Next C1 dash, D1 dash are far away from the observer, right? Far away from the observer. That's why corner C1 and D1, the edge which is those corners are invisible. The edge which is passing from those corners also invisible edge, that is a dashed thick line. Then axis line I show it. That completes second position top view, right? Now what is the third condition is given? The resting edge is inclined to VP at 30 degree. That whatever the dimension given is VP, that you have to show in HP, right? The resting edge, is there any resting edge changes its dimension? That is C1 D1 is 40 mm only, right? C1 D1 also is 40 mm. That resting edge does not change its dimension. Now which method it is? It is a normal or direct method, right? Now draw a line which is parallel to XY line. From that you draw a 30 degree line on the 30. This is a 30 degree line. On the 30 degree line rest the resting edge. What is the resting edge? Is C1 D1, measure 40 mm. Just rotate this second position top view solid, place on the 30 degree line. How do you place? Once you mark C1 D1, from the point C1 draw a 90 degree line. From the D1 also draw a 90 degree line, right? On the 90 degree line, now with respect to this, through the compass measure the dimension, right? Then after that, how do you get O1? O1. Best example here, I will go for arc method. Instead of arc method, as you know that what is the base corners A1, B1, C1, D1. Just join the A1, C1 diagonal corners and D1, B1 and D1 diagonal corner. The intersection point will get O1. Similarly, top face is A, B, C, D. A, B, C, D, right? Then just join this, draw the diagonal A to C and B to D, the intersection point will get O. Right, that completes our third position, top view. Then draw the vertical projector from the base corner. First you draw vertical projector from the base corner and the horizontal projector from the base corner in the second position, front view. The intersection point you name it as A1 dash, B1 dash, C1 dash, D1 dash. Then you go for a top face corners vertical projectors from the third position, top view. From the second position, front view, draw a top face corners horizontal projectors. The intersection point will get A dash, B dash, C dash, D dash. Then apply the rules of visible and invisible rules. That is, one is all outlines are visible. The corner which are near to the observer, that is visible. The edge which is passing from the visible corner is also visible edges. Right? So try to solve this problem. Yes, our next problem is problem number 44. Is a tetrahedron of 55 mm sides rest on one of its corners such that an edge containing that corner is inclined to HP at 50 degree and VP at 30 degree. Draw its projection. Now read the problem once or twice, understand it. Here what type of solid is given? Tetrahedron. Write the given tetrahedron. What is a tetrahedron means? The base is a triangular, equilateral triangle. Okay. Then apex also is there. From the apex to the base corners, the line which joining, that is slant edges. The slant edges are having also the same size of the base edge. That is, what is AB is equal to BC, that is equal to CA. What is the dimension is there? Same dimension is also, sorry, this is 55 mm. What is the size of the base is there? The same, the slant edge also having the same size it is. Slant edge is OA, OB, OC. The having also the same dimension of the base edge. That is 55 mm only. That is called as a tetrahedron. It's having a how many faces? 3 triangular equilateral. Sorry, 4 equilateral triangular faces. Equilateral triangular faces. That is called as a tetrahedron. Right? It is having a base, apex, the axis, and the slant edge and slant triangular face also. One more is slant, a triangular face also. It is slant triangular face. Okay, that is called tetrahedron. Now see the tetrahedron, 55 mm sides. What is the base sides? All the sides are equal in length, that is 55 mm. Rest on one of its corners. What is the resting condition? Rest on one of its corners. Is not given either on HP or VP. We assume it is rest on HP only. Okay, rest on one of its corners. Yes, right. Tetrahedron of 55 mm sides rest on one of its corners such that an edge containing that corner is inclined to HP at 50 degree. The edge containing that corner. What is the edge containing that corner? Edge is nothing but, assume here, slant edge. Is not a base edge, is a slant edge containing the corner. And one more is resting on here, assume it is rest on HP. On, there is also assume it on one of its corners. Now the edge containing that corner, that is slant edge, inclined to HP at 50 degree and inclined to VP at 30 degree. Right? Now we will see how to solve this problem. Now this is a tetrahedron. Similarly, what we saw that a triangular lamina or the corner condition, same thing you will go for construct it. Draw a vertical line. Along the vertical line is measure 55 mm. Through the compass, take B is the center, A is the radius, B is the radius, draw an arc. Similarly, A is center, AB is the radius, draw one more arc. The intersection point will get point C. A, B, C, this is a base corners. How do you get apex? That is, just take the one corner, the opposite side, middle point, draw a line. Then you take one other corner, the opposite side, middle point, draw a line. The intersection of these two will get the center of the base and also apex. Name it as O and O1. O and O1. Then join that continuous thick line OC, OA and OB and show the dimension. That completes the first position top view, right? And project all the corners vertically upward. Now the base corners B dash visible, A dash is invisible, O1 dash, C dash. Then draw a axis line O1 dash, O dash. I don't know the length of this axis line. How do you get this length? Once you project these corners, base corners, now which slant edge is parallel to VP? See that see the note. The slant edge OC, the slant edge OC is inclined to HP and parallel to VP. Now this is OC. This is slant edge is inclined to HP, that is a reduced length, not 55 mm, but parallel to VP, right? There is this line, the slant edge is parallel to HP and parallel to VP and inclined to HP, that condition. Now once it is parallel to VP, what is the slant edge? The dimension should be also same because the tetrahedron, all sides are equal. So from the C1, measure this 55 mm through compass, draw an arc that touches the axis line, that you get O dash, right? This is 55 mm. Then draw the line O dash to C dash and O dash to B dash. That gives a first position front view, right? So understood this one? Yes, remember this point and remember that line is parallel to one plane, inclined to another plane. Means here line is parallel to VP, inclined to HP. That method. Slant edge OC is inclined to HP and parallel to VP. Once it is parallel to VP, means you will get the true dimension where in that line which is parallel, parallel to the plane, that there will get the true length, right? That first position over. What is second condition? The edge containing that corner inclined to HP at 50 degree. What are the dimension given with respect to HP that I want to show in VP? What is the rest containing that corner? The slant edge OC is a edge containing that resting corner, right? Now mark a point on the XY line C dash. From the C dash, through the protractor draw a 50 degree line. Along the 50 degree line, how much you just measure here? 55 mm, and mark or draw an arc on the 50 degree line. Then you'll get O dash. C dash we know that, O dash we know that. Then how do you get B dash? We know C dash, B dash. Take the C dash center. C dash, B dash is the radius. Draw an arc. Similarly, O dash is center, B dash is the radius. O dash, B dash is the radius. Then O dash is center, and draw one more arc. That intersection point will get B dash of A dash. Then join the line C dash, B dash, A, O dash, and O dash, C dash. Then how to get O1 dash? Measure this C dash, O1 dash is the radius through the compass. Take center C dash, and O1 dash is the drawing arc that touches the C dash, B dash line. Then draw the vertical projectors from all the corners of the base and the apex of the tetrahedron. Then horizontal projector from the first position top view. The intersection point will get A, B, C, O1 and O. Now apply the visible and invisible lines rules. All outlines are visible. A to B, B to O, O to A. Now here is the observer. Now C dash is far away from the observer. Means the corner, the C is invisible. Once the corner is invisible, the edge which is forming from the corners C to A, C to B, C to O, those are invisible edges, right? Then O1 to O axis line. They complete second position top view. Now what is the next condition? Again, this edge containing that corner, resting corner, is inclined to VP at 30 degree. What are the dimensions given VP that I want to show in HP? Now tell me whether it is the edge is changes its length or remains same. Which is the slant edge? Here the slant edge is 55 mm. Here the slant edge in top view it is OC, it is how much? 35 mm. Now it is reduced length, right? Now which method it is, normal or beta method? No, it is beta method, right? Once it is beta method, first draw a line which is parallel to x4 line. From that you draw a 30-degree line. Along the 30-degree line you measure the slant edge based on, right? What is the true length of the slant edge? O1 dash, sorry, O dash C dash 55 mm. Along the 30-degree line measure a 55 mm, that is OC along the 30-degree line. From this point you will get a locus of C. Draw a horizontal line that will get locus of C. Then take the second position, top view. OC, how much it is? 35 mm. From O, draw an arc that touches the locus of C, that you will get the second position, right? Top view, that's OC, that is the line. If we extend this joint C to O and extend that line, that you get beta line, right? Now beta is how much angle you will get. Okay, you will not measure here, measure it is, there I will tell you this angle. Okay, next after that, now just rotate this second position top view on the beta line, right? We know the O and C, right? O and C, we know that. So O1 will get along the beta line only. Then how do you get point A and B? Just take this C is the center, CA is the radius, that is equal to CB. C is the center, then draw an arc on the either side. Then O is the center, OA is equal to OB. O is the center, draw one more arc. Now you just rotate this, the solid on the beta degree. Now A will come this side corner, B will come this side. Then just replace this, then draw the lines, the O to A to B, B to O, right? That completes the third position, top view. From this we'll draw vertical projector. From the third position top view, draw horizontal projector. From second position front view, the intersection point will get like this, right? Now apply the visibility and invisible lines rules. All outlines are visible. There is C dash, B dash, B dash, A dash, A dash, O dash, O dash, C dash. Now this observer, now which is now the corner A is visible, right? Nearer to the observer. Comes to see the B and C. From these two corners, which is the corner is nearer to the observer? C is near to the observer, right? The corner C is near to the observer compared to the corner B and C. Now the edge which is formed from A to C is visible, that's why it continues thick line. Then O dash B dash, the B is away from the observer, O is also away from the observer, that is a dashed thick line. Then show the axis line. Yes. Now that completes the problem number 44. That completes the module 4 solids. If you have any doubt, please contact my number. And in this primer, that is in the primer, the problem related freely suspended of solids, that is not in your syllabus. Okay, please forget about those problems. Remaining problems you try it. If you have any doubts, please contact to my number. Thank you for watching this video.